Good afternoon. So one of the important topics is reading of graphs in class 11th, when you start doing kinematics. So if we talk about reading the graphs, one of the last graph we would like to study is the acceleration versus time graph. So let me explain how do you read an acceleration versus time graph. So if you have an acceleration time graph which looks like this. Okay, let me just draw it for you. So there is a body, and the acceleration is shown here, and this acceleration is 2 meter per second square, and it is maintained for a period of 2 seconds. And then the body has no acceleration, maybe for next 4 seconds, and then this body, has deceleration, which is also, -2 meter per second square. So the x-axis is always the time scale. Okay. Now, how do you read such a graph? What type of information this graph tells you about this body? Obviously, it tells you that this body accelerated for a period of 2 seconds with an acceleration of 2 meter per second square. And then the acceleration became zero. And from 2 to 4 seconds, maybe 2 to 6 seconds, there is no acceleration. And from 6 to 8 seconds, you have deceleration. So this graph, tells you this information. Now, apart from this, the very important characteristic of AT graph is that the area under the curve of an AT graph, tells you about the change in velocity. Okay, how much velocity changed? So if you calculate this area, which will be length into breadth, 2 into 2, it will be 4 meter, per second. This is the change in velocity, that happened in a period of 2 seconds. And if you see the physical world, since the body must have some, velocity at t is equal to 0, and it accelerated for 2 seconds, it gained some velocity. So that gain is this, right? Similarly, this body, the area also represents the change in velocity. But since this is a deceleration, the change in velocity will be negative, which means the body lost velocity, right? So if you are in the fourth quadrant and you calculate delta V with the help of area under the curve of AT graph, you will get loss of velocity, right? And which is also a change, right? So this is also a change in velocity, but it's a loss. But here it is the change in velocity, but it's a gain in velocity. So if you want to find out, how do you read an AT graph, fundamentally your whole focus is how do you, calculate the change in velocity. So remember, AT graph helps you identify change in velocity. I hope this helped you. Thank you very much.